Very good morning. Today is our third day of the workshop. We're going to discuss on machine learning based state of charge estimation for lithium-ion battery that and that interfacing of C2000 launchpad with MATLAB and PW signal generation. The session will be taken care of by Mainak Biswas. Okay. So I hope that session will be very useful to your end. So thank you. We can start the session now. Why not?
Yes, yes. Screen is properly visible, right?
Yes, it's properly visible at full screen.
Okay. So, a very good morning to all. So, I am Mainak Biswas. I am a PhD scholar in NIT Rourkela under the supervision of Dr. Arnav Ghosh. So, today we are discussing about the TI's flagship real-time control MCU, that is the F2383790, that is a C2000 microcontroller. It is a part of the C2000 family. So let's start. So in the presentation, we'll cover the introduction part, like what is the C2000 Delfino series, what is the architecture, uh, means the model number. We are focusing on the model number like F28379D. That is a basically dual core CPU design. Uh, it is available in single core also, but in our case that is dual core. We are discussing about the dual core design. So we'll next cover the co-processors like the control law architecture, that is CLA, the peripherals like the sensing ADC. ADC means the analog to digital converter, the DAC like digital to analog converter, like that. So and the control PWM, that is the pulse width modulation techniques using that C2000 microcontroller. So coming to the application, we'll apply that in our power electronics devices as well as the motor control and the digital power systems. Okay. And after that, I will try to cover the C2000 code deployment from the MATLAB, and I will see how to deploy code into the C2000 microcontroller. So here, what is C2000 basically? C2000 is nothing but it is a general purpose CPU chip basically, and it is a built-in high-speed deterministic control loops. Okay, so what is a microcontroller? Like we know about microcontroller, we already know about the microprocessor. The basic difference between the microprocessor and microcontroller is the memory. There is a lot of difference, but the basic difference is the memory. So in microprocessor, we don't have any memory, but in microcontroller, we have some memory. So, so what is the C2000 family? So what is C2000 family? We are focusing about the C2000. It is a 32-bit microcontroller, and it is designed for the real-time processing like sensing, actuation, like that. So the C2000 is specialized for 32-bit MCU. It is a 32-bit MCU, that is the specialized thing. Like we don't have that 64-bit. Like that is the processing power is very fast. But for now, we are focusing on the 32-bit MCU. So what is the main thing in C2000? Like there is other MCUs are available in market. Like why C2000 microcontroller? Unlike the general MCUs, it accelerates the deterministic low latency. Okay, so that is the deterministic low latency. And math intensive closed loop control. That is the math intensive closed loop control. That is the main thing inside the C2000 microcontroller. Okay. So there is two type of series in C2000. Like one is Piccolo and one is Delfino. So what is Piccolo? There's a Piccolo means there's a number like F280X. That is the series number for Piccolo series. It is an entry level uh, series, like it is a low cost series. Piccolo we are using for low cost series, and it is ideal for simpler or cost sensitive applications. Uh, if the application is cost sensitive, then the Piccolo is comes into picture. Okay, and the another thing is Delfino, like F283X. This is used basically for the high performance series, like feature like floating point units. Like what is floating point units? APU, higher core speeds. If you need higher core speed, we can use Delfino, and the most advanced peripherals. Okay, so uh, in this particular series, like in our case, that is TMS 320 F2879D. That is a flagship product in the Delfino series. That is comes into Delfino, okay, for the high performance and offering the dual core maximum performance. This is comes with dual core, not a single core. Okay. So moving into the next slide, that is the architecture of the uh, C2000 microcontroller. So the Delfino is the high performance. Okay, so that our C2000 microcontroller, whatever we are discussing, that is the Delfino series basically. Okay, and now the key highlighting part is the dual core 200 megahertz C28X CPU. That is the 400 MIPS total 400 MIPS, and that is comes with 200 megahertz CLS, and the flash storage is 1 MB. Okay, with ECC, like it packs 200 megahertz CPUs. This is huge basically for the microcontroller, and two matching control low accelerators, and is providing exponential parallel processing. We basically for the real-time applications or real-world applications, we need the parallel processing. Without the parallel processing, the uh, work is basically incomplete. So that's why the parallel processing is needed. So for that C2000, the parallel processing is comes into picture. Uh, See, here I have pasted one MATLAB simulating model. Like this is the high level block diagram. There's a block diagram. Uh, the block diagram comes with the system on chip nature. Okay, so this is the least integrated components like C28X core, that is FPU, TMU, and the CLS. So for the advanced sensing and the advanced control like EPWM, so like pulse width modulation techniques, and the connectivity, like for connectivity like CAN, you can say USB, like that. So in GIST, it is a complete system integrated dual processing course with advanced peripherals and like ADCs. Like ADCs means analog to real converters, and the EPWMs like pulse width modulation uh, on the chip. So what is the advantages for the dual cores? So the utility of the dual cores, like that is used basically for task partitioning. So we'll partitioning the both tasks. So, like if you consider two tasks or two or more tasks, like we can partition.
So now
Like
we'll discuss the implementation of this T-type LPC circuit.
sorry, ma'am. Hello.
Circuit.
Hello. You are not properly audible. Hello.
And, so we'll start with the charging mode. So during charging, the NPC converter acts as a rectifier and the power flows from the grid side to the battery side.
Hello, ma'am. Are you talking with me? If not, please mute yourself. Hello.
Power electronics lab ഞാൻ ഒരെണ്ണോട്
It
power
seems
electronics
she's
lab
not talking to you, sir.
power electronics lab ഇല്ലേ
Maybe for by mistake.
Hello. Please mute yourself.
Okay, I am muted. Please carry on.
Okay. So, what is the advantages for dual core? See, that dual core is basically for the task partitioning. So if you start with two or more tasks, we can partition the tasks, like some tasks in the partition 1 and some tasks in partition 2, like that. Then that is also called as the parallel processing, like NPPs, DCAC inversions simultaneously. So that is basically for functional safety, and one core is monitored to other core. So there is two core basically, and one core is monitored to the other core. That is the main thing. So in gist, the dual core is the key complex for the system, and we can run two fast control loops in parallel, or you can say dedicate one core to safety and diagnostics. So that is the thing. So moving into the next slide, like what is C28X core feature? We have two C28X, like into two means we have two C28X, this is dual core. That's why into two is added. So focusing on the thing, like in detail, the hardware accelerations in the main CPUs, like FPU32, that is the 32-bit floating point, and the TMU, the trigonometric math unit for FOC, that is for motor control, and the VCU2, that's for the complex math systems. So in gist, what we can say, like each C28X code is optimized for math, including the 32-bit APUs, like and the TMU, which gives us hardware acceleration for trigonometric functions and essential for the FOC. That is the part. So now we are focusing about the control law accelerator, that is CLA. The CL is the main part for the C2000 microcontroller. So what is CLA? The CLA is truly basically differentiate the C2000 from the other MCU. Only for the CLA, that C2000 is the different from the other CPUs, other MCUs. What is CLA? That is two independent, like 200 megahertz and the 32-bit floating point core processors, and it's specialized to design to execute the math heavy tasks. Okay, execute the math heavy tasks with direct access to the peripherals. So if you see, like it is separate 200 megahertz floating point CPU or designed specifically for high speed math tasks. and it has direct, fast access to the peripherals. Okay, so if you see like how CLA works basically, uh, before that I will show the MATLAB, show in MATLAB like how you set up a C2000 microcontroller in your MATLAB and deploy the code through the MATLAB. We can use CCS, that is Code Composer Studio, that is official IDE, Integrated Development Environment for the C2000. But for now, we are using MATLAB to uh, deploy the code into the hardware. Okay, so first you just go to add-ons and search for get hardware support packages. If you click on that, there is one package is available. Like if you see, if I search C2000, see the first result is embedded coder support package for Texas Instruments like C2000 processors. That is the main component to how to uh, communicate the C2000 with our MATLAB. That package we need. Okay, that is the main package. But one thing is that like after MATLAB version 2022B, that package is not. One second. The package is not there for after 2022B. So we have to download that 2022B, in my case 2022B. Uh, so you have to download that one only. For 2022, after 2022 B, it should be available in other name, but in my case that is not working for now, and I think MathWorks has some other idea. I don't know, but it is basically used for the communication to our MATLAB and the C2000. So that is the main package. After downloading, I have downloaded in my system. After downloading, we have to click on the manage, and so we have to set up the package. If you click on that, one second. That is for the hardware setup basically. Okay, so select the processor from the list. For my case, first I unselect total, and for my case that processor is TI Delfino F2837D. That is my processor. In my case, if you use if you are using other processor, like there are so many processors available, so you can select it. Then click on the next. Then you can choose the automatically download and install the third-party tools like TI C2000 code generation tools, TI ARM code generation tools that will automatically download from the MATLAB. You just click on the next. See, for that CPU, for my CPU, the three third-party software are needed to run the code. One is TI Control Suite. You can just focusing on the version. So if TI Control Suite, that is the version 3.4.9, and here in my case I have already downloaded. That's why that link is not provided. But in your case, first the link has been provided here. and you have to focus on the version. That version only you can just download it. Okay, for different processor the version can be changed. In my case the version is 3.4.9. I have downloaded that 3.4.9, and here is showing that upgrade not required for the selected processor because I have already downloaded. And the next one is TI Code Composer Studio, that is CCS basically for the official C2000 microcontroller, and that version is 11.0.0012 00012. That is the version I have downloaded, already downloaded. That's why that is showing upgrade not required. In your case, from the first, you will show the download option here. Okay, and that will redirect to the TI website to download the product, basically download software. And the next thing we need, that is the C2000 wire, and the version is just focusing on the version. If you download a different version, that will not work. Okay, for my case that is 4.0. That and here is showing upgrade not required, means I have already downloaded that three softwares for my processor. Okay, if you click on the next, it is just validate the installation path. To just click, if you browse the path, you can select the path, or else you can just click on validate. Okay, and the tick mark is given, like the all selected processors are supported. And if you click on the next, same, so the validate C2000 wire, we have to validate this thing also. Click on the validate, is validation successful, and click on the next. So following a summary, whatever we have downloaded, there's a summary of third-party software information and the version. So first one is TI Control Suite, that is 3.4.9. Then another one is TI Code Composer Studio, is CCS basically, that is 11.0.0. And that is TI C2000 Wire, that is version 4.0. And TI C2000 Code Generation Tools, that is a compiler basically for that's the version is 20.2.1. And the TI ARM Code Generation Tools, that is also a compiler, that is version is 20.2.1. That is the MATLAB thing. If you want to see the CCS, the CCS is looks like that. Is see this is the CCS, the Code Composer Studio. There is an official ID. It means integrated development environment for the C2000 microcontroller. You can just compile the code or deploy the code from here also. Okay. Now we are focusing on MATLAB. Okay. So up to that thing, we have done. Now click on the next, and that is generating this hardware setup has been completed. And if you click on the finish, that will finish. And there's a documentation part. Okay. Now up to that, our thing is ready. Okay. Okay. See, now we already created two blocks. That is for pulse. That is basically the PWM1 and PWM4. That is a very basic for the gate pulse. Whatever we have supplied to the gate drivers. For that, we have created two blocks only. That is a very simple thing. See, that is the specifications basically. So if you click on monitor and tune, that will monitor and tune in the C2000 microcontroller. And if you after that, if you click on build and deploy, it will deploy to the specific C2000 hardware, and it will just uh, work as a gate supply or gate driver supply from the C2000 microcontroller. That's it. So I will deploy and build. I will later discuss, and now I'll continue to the slides. Okay. Sorry. So basically, how the CLA, CLA means how the CLA works basically. So this is direct peripherals basically for the mechanism like ADC triggers like CLA platforms calculation like PID loop, and the CLA OS result is directly to the EPWM bypassing to the main CPU. Okay, so we can bypass the main CPU also, and it allows the C28X to handle the slower tasks also. Okay. Hello. Am I audible? Hello. Hello. Am I audible?
Yeah, yes, sir.
Yes,
Hello.
yes.
Sorry. Hello.
Yeah, yes, sir. Your voice is audible on the.
I'm audible, right?
Yeah, yes, sir.
One second. Hello. Am I audible? Hello. Hello. Am I audible now? Audible now?
Yes, sir, you are audible.
Yes, but from my PC, the connection is gone. Please, please wait for 2 minutes. I'm
I'm
reconnecting, and
reconnecting and
we'll resume. Will resume.
Sir, but there is resound, sir.
Wait for 2 minutes. I'm reconnecting from my PC. I'm reconnecting from my PC.
I I'm not getting any sound so far, and nothing is even visualization is lost. So no presentation at present.
So now screen is visible.
Screen is not visible. Your sound is available now. Now it's all there. Okay.
Now screen is visible, right?
Yeah, perfect.
Okay, okay. Just a minute. Okay. So what is CLA? Basically, the CLA bypass the main CPU, and the ADC triggers a task. Like the CLA runs the PID. A PID basically is loop, and it writes the PWM register, and is independently filling up the CPU. That is the main purpose for the CLA. Okay. So moving into the next slide, the task partitioning for the C28X versus CLA. Okay, so there's a differentiate task roles, like C28X handles the slower task, complex tasks like initialization, communication, like state logic, like that. And the CLA handles fast tasks like heavy math tasks, like high speed PID, FOC algorithms, uh, transforms, filtering, like that. Okay, so in gist, the we told that like C28X handles the system level tasks like communication, uh, while the CLA takes on the heavy lifting, the fast repetitive math like high speed PID loops and the FOC transform basically. Okay, so the next thing is the key peripherals and the sensing and the control. Okay, so here we are focusing on the sensing for the hardware. Like this took the sensing like capabilities, the feed data into the C2000 microcontroller to this powerful cores. There is a two cores available, I already told. So with this two cores, like powerful cores, we are sensing capabilities, and it will feed the data to the C2000 microcontroller. And the next thing is like analog to digital converter, like ADC subsystems. So if you summarize the subsystem, like 8 independent ADC modules, like 2 resolutions for 16 bits. It is for the high precision, and the 12-bit for the high speed, and its maximum is 35 point, sorry, 3.5 is that is for the 12-bit, and the 1.1 that is for the 16-bit basically. So we have total 8 ADCs in this, and with dual resolutions, and 16-bit for the precision, and 12-bit for high speed sampling up to 3.5. Okay, now if you want to see the pin diagram for the C2000, I'm just searching on Google. So this is the pin diagram. One second. that is a user guide for the particular awards model like F28379D is a launch pad. So if you download it, you will see the main microcontroller architecture here. So there is a power LEDs. Okay, so here is the power LEDs, and there is a reset button. That chip is basically the for the microcontroller. That is the main chip for the microcontroller. That is a launch total thing is the launch pad. But if you have the microchip, the C2000 microcontroller, you can build your own chip also, own microcontroller also. So here the ADCs for here the ADCs, here the 40 pin for booster pack connectors, and this is the debug probe. Uh, this is onboard 5-volt enable jumper. Like from that you can just get a 5-volt supply. And
Sir, I think we are seeing your download screen. We are not seeing the screen.
so your voice is not coming properly.
We are seeing your downloads folder.
Picture is not visible, right?
Yes, sir.
Yes, yes. Okay, okay. Yes, I just noticed. Wait. Well, I'm share it again. Now any screen is visible.
No, sir. Still it is not.
Wait.
Yes, sir. Now it is visible, sir. You are speaking about that board overview, right?
Yes, yes. Now it's visible, right?
Yes, sir. Yeah, PDF is visible.
Yes. Okay. So this is the C2000 microcontroller, basically the architecture. So here we have the power LEDs. See the power LEDs here. See the boot configuration switches is here. The boost configuration switches. The reset buttons, and that is the main chip. See the main chip. Like TMS 320F28379D, that is the microcontroller, and including the all the ports like power LEDs, connector, jumpers, reset buttons. Here is the main chip for the C2000 microcontroller for that launchpad. It's like if you are using a launchpad, then for testing purpose that is okay. But if you uh, using the real world application, like if you manufacturing something, like then that time you can't use the launchpad. So that time you will use the chip basically. So with this chip you can build your own C2000 own microcontroller, like probes, like connections you can build. Okay, just you have to purchase the chip also, the microcontroller chip only. Okay, so here what is that for the 40 pins? Hello. Hello. Any question? Hello. Okay, so there is a 40 pin for boost pack connection, for boost pack connectors, and this is the debug probe. Okay, And this is the ADC for differential pair inputs. This is for power jumpers. Okay, this is for high density connectors. Okay, so now if you see, 1 second, that is visible.
Yes, sir. Visible.
Yes, sir. Visible.
Yes, there is a pin diagram basically. What about the pins is available in C2000 in this launch pad. This is the pin diagram. If you just go through the pin diagram for the connection purpose of your specific project. So in my case, I am just sharing the pin diagram. You can just see it. The ADCs, the analog pins, the digital pins, the PWM pins. There is GPIO, like general purpose input output pins. Like this is the ground, 5-volt supply, 3.3-volt supply, like that. Okay. And the C2000 microcontroller is look like that only. 1 second.
Sir, the leftmost and the rightmost pins that are available are the pins that it can be connected from the external sources, right?
Yes, external sources.
Okay, sir. I have one doubt, sir, not in this particularly. If we are about to connect this Modbus communication, sir.
Sorry?
In Modbus communication. So when we have a TX, RX, that A and B pin coming from the meters.
Transmitter and receiver, right?
Yes.
Transmitter and receiver, TX and RX.
Yes. So we have that A and B pin. And when we are trying to connect with the microcontroller, we are using some TTL converter. I could not map the addresses because here we are assigning some pins of this IC to some other things. So how can we find the exact address of this pin, sir? Because it is masked, right? So the previous figure where you showed, we have converted that in 3 masking layers we have.
Okay, 3 masking layers. Like if you are using TX and RX, like transmitter and receiver, you have to map with the pins basically. So that TX, while uploading the code, that is the TX RX communication system, you have to open that TX or RX. Then you have just upload the code. Then putting back the connection TX and RX. Okay. So if you try to upload the code in TXRX and simultaneously the connection is already there, TX and RX, then the code will not be uploaded. Okay, you have to open the TXRX pins, then the code will be uploaded. And the pin, whatever the pin, that is same for Arduino microcontrollers also. Okay, in the same time you can't upload the code. You have to open like TX and RX pins.
Okay. We have to open that and then only we can upload the code.
Yes. Otherwise, it will just start.
Okay, cannot be overwritten. Okay. Thank you.
Okay. So this C2000 microcontroller is looking like that. Actually, I don't have the exact picture, but I already in my hand the C2000 microcontroller, but I don't know how can I show. Okay. So you can just read the documentation first to use the C2000 microcontroller particular module. For that particular module, in my case, this is the documentation. And for the other other boards like other processors, you can just search on Google. That's the TI website, official website. You can find the pin diagram in depth. Okay, that is not a problem. Any question till now? Okay, so we can carry on. So up to this, everybody clear? Okay, I think no more questions. Okay. Now moving on to the next slide, like what is 16-bit differential ADC. So I have pasted one circuit here. Just you can just see the circuit. So we'll explain the 16-bit resolution. That is the numbers, the 16x 12-bit. Okay. That emphasize the differential capability, which is crucial for rejecting common mode noise. That is basically rejecting the common mode noise in harsh environment like motor inverters or the power electronics components. Okay, so if you see, like the 16-bit ADCs offer much higher resolution, like more importantly, they are differential, which is essential for the rejecting noise when measuring the currents in power electronics. Okay, so next slide, like that 12-bit single-ended ADC. What is a single-ended ADC? It's high speed, like 3.5 MSPS. Will explain the single-ended. What is single-ended? The voltage relative to the A ground. Okay, and is least the common users like DC bus voltage, is temperature, general monitoring, like that. So in 12-bit ADCs is running at the 3.5 MSPS are perfect for fast general purpose measurements like DC bus voltage and the thermistors. Okay, like other sensing peripherals, like we are focusing on the highlight of sigma delta filtering module, that is called as SDFM, or for high noise immunity current sensing, like enhanced quadrature encoder pulse, that is EQEP, for the motor position sensing, and it is also include the analog comparators for the fast trip zones and the peak current control. Okay. So the
సార్ కి చూపించరా సారా మీరు నాకే చూపించారు లేదండి
please mute
మరి
yourself.
దానిలో తప్పు ఇక్కడ వచ్చింది మీకు అవుట్పుట్ వచ్చిందా నేను చూస్తాను సార్
Hello, please
నాకు
mute yourself.
ఒకసారి చూస్తాను నెంబర్ తర్వాత చెప్పండి సార్ నా పేపర్స్
Hello,
లేదు
madam.
నా దగ్గర చూడటానికి ఎక్కడ
Please
తప్పు
mute
చేశారు
yourself. Okay, so for other peripherals include the SDFM, like sigma delta filtering module for the robust isolated current sensing, and the like enhanced quadrature encode pulse modules for the high resolution motor positioning feedback. So the key peripherals, that is the control part basically. So selection for the title of the control hardware, that is the actuation and the waveform generation. We'll speak about the like after sensing and the processing, we need to high resolution acceleration. We need basically the high resolution acceleration, which brings us the EPWM like modules. Okay, so it is basically comes with the trip zone protection, integrated deadband like hardware control deadband, the prevent of the shoot throw like the half bridge inverters like that. Okay, so the next slide is the high resolution PWM, that is called as HRPWM. The HRPWM that is a 16 channels, and it uses a special analog circuit like MEP to add the 150 picoseconds, like what is the picosecond, that PS of resolution to overcome the clock limit of the standard PWM. It's critical for the high frequency digital power supplies. And if you see, like high resolution PWM gives us the sub nanosecond precision, and it's vital for the high frequency power conversion. Okay, and it is also offering the better control over the waveform and the standard clock limited PWM. Okay, now this is for the other control peripherals like okay, so other control peripherals like list of remaining modules like 3-bit 312-bit buffered DACs for the test or set points of the C2000 microcontroller, and the ECAP modules for the precisioning of the timing or the speed measurement, and the memory that is for the 1 MB flash drive, and one is 204 KB for SRAM, the static RAM. Okay, and we also have the DACs for the analog output, and the ECAPs for the timing and the speed measurement, and substational memory, that is 1 MB flash for the complex application code. Okay, so what is the real world applications for the C2000 microcontrollers where you use basically? So we have used the real world application like the chips peripherals are used in a single high efficiency servo drive. We know the servo drive like EQEP, like ADCs, like CLS, like EPWMs, like EQEP means the position, ADCs the current, and the CLS like FOC algorithm, like EPWMs for the gate drive. Okay, so if you consider like in field oriented control, the entire loop runs efficiently, and the ADCs and the EQEP that is feed the data, and the CLS execute the FOC math, and the EPWMs generate the inverter signals. I'm trying to give the circuit here. You can just see. Otherwise, I can also share the PPT. Okay, so now in the application of solar inverter, we can use that one. Okay, so there is a perfect example for the dual partitioning CPU1 and CLA1. CPU1 and CLA1, the both thing run into the high frequency MPPT. Okay, and CPU2 plus CLA2 manage the DC to AC inversion and the grid synchronization. That is the perfect example. Okay, you can see the solar inverters show the dual core advantages. one core manages the MPPT boost stage, and while the second core handles the grid synchronization and the AC inversion. Okay, you can see in the picture. One second, it's dragging it. Okay, see the picture. There's basically the best example for the dual core partitioning. CPU1 and CPU2 CLA1, that is I'm telling again, CPU1 and CLA1 runs the high frequency MPPT, and CPU2 and CLA2 manage the DC to AC inversion and the grid synchronization. Okay. Okay. So the next slide is the EV is the most advanced and common thing nowadays. Like the application of EV, there are a lot more research on it. So the EV onboard charger that we can also deliver, or we can also develop some system in EV onboard charger using the C2000 microcontroller. So the highlighting part is we need to high frequency power. We need the high frequency power, then the FPC for the DC to DC stages both record the HRPWM, like we already told the PWMs, like the CLS, the main CPUs here. What in EV chargers it require the high frequency control, and in both the PFC and the DC to DC stages, utilizing the HRPWM for the precision. The main CPU handles the vehicle communication via CAN bus. We already told that CAN bus is available. So in EV chargers requires high frequency control in both the PFC and the DC to DC stages, utilizing the HRPWM for the precision, and the main CPU handles the vehicle communication via the CAN bus. So those are the other key applications, like the grid inverters, like UPS battery storages, the industrial robotics, the multi-axis servo drives, digital power supplies, like high density AC to DC converters, like that. Okay. So is the in this it is also widely used in the robotics application for the multi-axis servo control and the high efficiency digital power electronic supplies and the grid inverters. Okay. The next slide is for the ecosystem development, the ecosystem. So I already told how to develop the ecosystem, like the C2000 microcontroller. We can use the CCS, the Code Composer Studio. That is the official ID, like integrated development environment for the C2000 microcontroller. But for now, we are just a time-consuming thing. Like, so that's why we are using the MATLAB for the for upload the code to the C2000 microcontroller. Okay, that is the launchpad basically. Okay. So I already told the Code Composer Studio, that is CCS. That is the Eclipse based integrated development environment. Means we already know about the Eclipse. Many people know about the Eclipse. That is the Java code studio, like Java IDE. That CCS is also a Eclipse based integrated development environment. Like it provides the toolkit chain, like it compiles C, C++, optimizer, and the linker. It has a powerful real-time debugger. So you can also debug the code. You can see in the picture there's a red dot. That is basically the debugger point. So if you know about the coding part, so you can debug step by step uh, how the code is running into the system. You can debug it. If you have any error, if you have any doubt regarding the code, how the code is flowing, basically flowing to the one line to another line, that is that debugger part. It comes into picture. It will see that into the debug system. Okay, and the system level trace and the uh, profiling tool to analyze the performance. Is the complete system, basically, nothing else. So that is the system uh, software C2000 wire and the SDK. I already told the C2000 wire is also required for the code generation or the code deployment in the C2000 microcontroller, and we need the SDK, digital power SDK also. The functional software like C2000 wire is a functional software package. It contains the peripheral drivers like driver lib, for examples, and the libraries. For programming, we use many of the libraries. Okay, so the libraries have a set of codes, like we can't rewrite the codes. Just we are call the libraries. The library will handle the rest of the codes. Okay, so we no need to worry about the codes, the predefined codes. And the next one is the motor control SDKs. That is basically uh, a optimized code for the running the FOC and the instance pane for and the other motor control algorithms. The next one is the digital power SDKs that provides the code examples and the libraries for the implementing common digital power topologies like PFC, LLC, etc. Uh, Now the summary. Uh, the TI provides C2000 wire for the peripheral drivers and the specialized SDKs like the motor control SDKs and the digital power SDKs to start our application development. Okay. So my slide part is over. Those are some image sources. So you can ask some questions.
Thank you, sir. Because we will work on it, and if you have any doubt, we will contact you, sir, because it's full of knowledge. But we have to have
Yes.
hands-on to have this.
Yes, basically we have some hands-on project also, but the problem is that the C2000 packages for MATLAB, the package, see the package, embedded
Okay.
coder support package for Texas Instrument, that package is not available for the recent versions. That is the main problem. So
Mhm.
in our in PC, in this PC, my PC is different. I am just presenting it from the another PC. Okay, so basically in that PC we are not set upping the C2000 environments. Okay, so we need to use the another PC. So that's why for now I am not showing how to upload the code. Basically that is the part how to upload the code. You have to select the board here. You have to select the hardware services, and if after that, if you click on the deploy, build and deploy, that will basically be uh, build and deploy to the hardware board. That is not a problem. But in this PC only, I'm not setting the environment. That's why I am not showing the output results.
No issue, sir. We will follow these steps and we will try
Yes,
to do
yes.
that.
After
Hello.
developing the blocks in MATLAB, okay,
Hello, sir.
you just click on the hardware settings.
Hello?
Okay, yes, yes, yes.
Sir, your screen is not visible, sir.
My screen is not visible.
MATLAB
Yes, sir.
screen is visible, sir, now, actually.
MATLAB screen is visible. I am just showing the MATLAB screen only.
Sir, once
Okay.
we deploy this, can we do with software in loop and hardware in loop with this?
Yes, yes, yes. You can do. Okay. So after developing the blocks, that is the block basically MATLAB blocks. Okay. And then you just click on the after connecting your C2000 with your laptop, then just click on the hardware settings. Okay. The hardware settings will be not available for the first time. Okay. If you click on the hardware setting, 1 second. Then it will open the page like that. Okay. The hardware implementation. Here you can select the hardware board. Like for my case, that is the board name, like whatever the processor I'm using, F2 8379D Launchpad. There is lot more launchpads are available, but in my case that is my launchpad. Okay, and you have
every
to
development board, majority of the development board kit will be available here, no sir? Hardware
yes,
board?
yes, 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 it will be available after you just make sure the packages. Okay.
Okay.
You have to download the packages from the I already told in the first 1 hour in the lecture, like go to the hardware board. Okay. And you have to select the hardware packages for C2000. Okay. And same for the we already did in Arduino. For Arduino, it will the same packages. Some packages are available. We have to download it.
Okay.
And after downloaded, the board will be available here. You have to select your own board, and the feature set for the selected hardware board. There is two options like Simulink or embedded coder hardware package support package, and the SoC block set. But you have to select the Simulink or embedded coder hardware package support package, the first one. Okay.
Okay.
Then the code generation, you don't need to change anything. Okay. Then that simulation target, no, nothing. Okay. Then you just apply and okay. Then those options like monitor and tune, build and deploy to start, those option will be available. Okay. So then if you monitor and tune, you can just click on the monitor and tune and build deploy monitor and tune option. Then that will monitor your system. Okay. And whatever the system you have developed here in MATLAB, and if you click on the build and deploy, that will basically deploy in your hardware, that deploy the Simulink model in your hardware. I have our system, like 1 second, I'm showing the ML part also, trying to share. 1 second. Just give me 2 minutes. I'm searching the ML part also. Actually, we have done those parts, but in this PC that is not available.
It's okay, sir. No issue.
I think 2022B. I'm trying to show the model. Just grab the idea. It will take some time. In my suggestion, you have to use one high-ended PC for those experiment, because that is the very GPU kind of things. Like That's why we have to use the high-ended PCs. In my laptop, that is not working.
Yes, sir. In laptop, it takes too much of time, and sometimes it's jumping out.
So this is the our Simulink model. We have already deployed the Simulink model to our C2000 microcontroller, and this is the ML part. I'm just showing the coding.
Okay, this ML block will upload all our the programs.
And yes, if you click on deploy to the hardware, then the total Simulink model with the ML function that will be deployed to the hardware. It will take some time. See, those are the ML algorithms. So see, this is the ADC blocks. So we already set some blocks like input channels. That is ADC IN14. That is a pin number for our case. That is a pin number for ADC input. One is ADC IN14 for my C2000, and another one is ADC IN3. We are using, those are basically pins for the C2000. Okay, and like, see, if I click 1 second, hardware system chip, hardware settings, it will not deploy, but I'm trying to deploy. Is working very slow. Still, I'm trying to show the things. Okay, so see, here it is selecting the next part, but I will change it to Simulink embedded coder and apply. And for processing unit, I'm selecting, it's automatically selecting the C28X CPU1. Basically, the another CPU is also available, but for now, I'm just processing unit is CPU1. Somebody is not hearing anything. So my voice is available. Hello, am I audible?
Yes, sir, you are clearly audible.
Sir, you're audible. Yes, sir. Yes, sir.
Okay. So, ma'am, please check your connection, or you can rejoin. Okay. So see the monitor and tune options is here. I am just click on monitor and tune. See what happening. Is loading. See, the 5% is already done. Here you will see the view diagnostic option. Okay.
So what's the role with the monitor and tune option?
Sorry.
What's the role with the monitor and tune option?
You can you can directly put the simulation into the hardware, but before that you can just see how it is working. It's a monitor. It is basically for monitoring purpose. Okay, but not deploying the system. Just you are just monitoring through the C2000 microcontroller. That is the purpose.
So why the block double? Why you are connecting double block?
Sorry.
There is a block between ADC and ADC. After the ADC,
that is basically for the calculating part. Like I'm showing. Wait, that is very much slowing. Because from the input pins, whatever the signals we are getting, that analog signals we are not directly used in our system. That's why we are calculating some parts in the double block. Then we are delivering that into the system subsystem. That's why we are using double for two input signals. From that pins like 14, 3, the sensor values, whatever we are getting in the analog values. Okay, we can't directly use in our system. That's why we have already done some calculation for that. Then we are directly putting it into the system. See, you can click on the view diagnostics.
So what's the other block one? Between double and gain, there is another block. What is that block?
One second. I am showing. Showing the code generation templates completed, but it will not upload. I hope. I'm trying to see the diagnostics, but touch screen is not present because the PC is very slow. Still, I'm trying to show the diagnostics. That will help you to how to deploy the code or the Simulink model into the hardware, C2000 hardware. Okay, so I think that is consuming more times. So I will request Arnab sir, if possible, to arrange 1 hour session for that. Then I will cover the total hardware things and how to deploy into the hardware. But for now, that is not possible. So I am requesting Arnab sir, if possible, please arrange 1 hour session, if possible. Okay, so I'm wrapping up. Just any more questions?
After double, there is a rate of transmission. That block is that rate of transmission, and double is the data type. We are using an 16-bit ADC, so or 16-bit ADC or 12-bit ADC, then double is the data type. You can also use the double inside that block also, ADC block also.
Yes, you can use. For my purpose, we are just sensing through the sensors, and the analog values we are giving to the double block. There is the calculations, some calculation. Then we are just putting it to the system. That's it. In your case, that may be different. Okay. So as per your hardware, as per your requirement, you can change your blocks. As per my blocks, like whatever the thing I want my in my output. That's why I'm using those blocks also. You can just change your blocks. You can try it by yourself. For my case, that is the blocks. You can easily change the blocks. You can use different blocks also. That is not a problem.
Sir, what's the block connected between the double and gain? What's the name? What's the block?
Sorry?
The connected block between double and gain. I think that's a rate transition block something. I want to know what's the name of block connected between double and gain.
Acha. Wait.
May I know about the block, what it is and why you are connecting.
Wait. Actually, my machine on hang. Wait.
Okay.
So better you can use the high-end PC for that application or that C2000 works. So low-ended PC, that is very difficult to work. Okay. I will share the name of the block. Okay. So for now, any other questions?
Okay, sir.
I'll show. Whatever I just told, you understand, right?
Excuse me, sir. Am I audible?
Yes.
Actually, some portion I missed, so I just want to know any specific machine learning algorithms in the state of charge?
See, as per your project requirement, you can actually no specific machine learning algorithms is provided. Okay. You can use as per your requirement. You can use as per your requirement. Okay.
No, I'm just want to know any research scope like patenting, like a specific algorithm. Not there means it's still evolving just now, or suppose not there means we can develop some own algorithm and can patent it.
Yes, you can develop your own algorithm. That is not a problem.
Okay, right. Thank you, sir. So I missed actually some portion the connectivity.
Yes, the video will be available. Anup sir will share in the group. Okay. I think by today afternoon, the video will be available in YouTube. Okay. So the previous question, you just want to know the block name between the double and K, right? Double and gain.
Yes, sir.
That is the block name is. 1 second. Rate transition.
Okay, sir. Why you use that block?
Sorry.
What's the use of that block? Rate transition block.
Basically, rate transition block we are using for the initial conditions. Okay, is handle data transfer between the different rates and the tasks. Okay, that is a handler basically, data transfer handler between the different rates and the task.
Can I see parameters on the block?
Yes.
If possible.
One second. I'm just trying to share my screen again.
Also for setting sampling time.
One second. Visible screen?
Yeah.
Yes, sir.
See, running hopefully that is running. Okay, that is running in my PC. Okay, see, the time is showing here, and if you want to see the rate transition block, see the rate transition block. Sample time is 0.15 in my case.
Okay, sir.
Okay, so it is working in my system. I don't know how it is working, but it's very slow. Okay, it's monitor and team is working, but I don't know the deploy and build it will work or not. Okay, so for now I am just stop it. Okay, then go to hardware. I'm trying to uh, build and deploy. Okay, so meanwhile, just you can ask some questions if you want. Otherwise, you can just sit. I'm just trying to show the hardware, but how to deploy the hardware. If it is working, then fine. Otherwise, just the steps should be same. You can just go through the steps, and it should be work in your system. And if you find some trouble in uploading the code, you can use the TI forum for the question answering. You can just ask the questions. Someone will available to answer your question to solve your problems. So that is not a problem. The TI forum is very good for my observation. Okay, so I think no more questions. And
may I?
Yes, sure.
Yeah. Sir, I would like to ask about the STM32-bit microcontroller, M4 Cortex series. So if we use MATLAB using Weijing block set, and we can interface STM32-bit hardware with that software, which converts the simulation into real-time results. So how is this TI microcontroller, I mean to say, this particular arrangement is different from that? And which one is advantageous, if you can address it?
STM 32-bit microcontroller, like?
Yeah.
You are using which microcontroller and which purpose?
I am, sir, using STM32F407 M4 ARM Cortex M4 core, and with
One second.
MATLAB and Weijing block set. Yeah.
Okay. So that actually I'm not used that STM32 board. Okay. M4 Cortex. Okay, but I don't know how it is works.
Okay.
For
The similar things, sir. Just like as
can
you.
I ask some questions?
As you shown
like,
it.
I already seen that thing, but how it is working? Can you please share your idea?
Yes, sir. Yes, definitely, sir. So it's just like as you shown the TI board, right? So likewise, STM32F4 series have many discovery boards, and we can use it for the real-time result purpose. Like as an just you used MATLAB, right, for interfacing the board with the simulation. Similarly, there is Weijing block set. So in Weijing block set, there is a library of 8051 as well as 32-bit controller, and we can design everything in the KL as well, and there is STM32 micro cube MX. So in cube MX, initialization part can be done. So when you write a C program, that initialization part will be automatically designed. You just have to configure your board, and you just have to add some numbers like what could be the AHB frequency, what could be APB frequency, then core and all that stuff. And similarly, you have to do the simulation in MATLAB using Weijing block set, and you can interface your STM32 discovery board with that. And similarly, you can run the simulation and you will be able to get the real-time results.
Okay.
So
Okay.
I thought that I thought like that you might have used. So if there is some difference, and if we can address some pros and cons between those, then we can utilize that thing in a more proper manner application wise. So I thought of asking that question to you, sir.
Okay. Thank you for your information. I will just
Thank you, sir.
try to research on that. Okay.
Sure, sir. Sure. Okay. Thank you, sir.
Okay. I'm trying to deploy and see. I don't know it will work or not, but monitor and tuning has been worked, but I don't know it will work or not. If it is working, then good. I think that will work, but it will take some time. Okay. We have some time. It's 10:39. So please, I will wait or I will wrap up. Audience, please.
Yeah.
I will wait
So,
or yes, you can
so
continue.
it's based on like you're collecting some data and over that it's learning, right? Machine in your machine learning algorithm, is it will it come under like a data driven type? Naturally, data, because it has to be learned through a data only, right? Observed data. And then learn over a period. So is a same kind of technique you are implementing? Because I missed that information. So initially you must be observing, monitoring the charging status, like state of charge. And then over a period when it's maintained the logbook and it learns over that data and can predict the next one, the state of charge. Is it the same thing happening here?
Yes. The same thing happening. Something different, but the logic may be same. Okay.
Overall
What
concept
about the logic is the state of charges, and that is storing, and that will predict some values. That is the same thing. The machine learning logic may be same, but
so in
the
such,
implementation may be different.
Okay, so in such case, usually the libraries, suppose you are monitoring some certain things, and usually in the machine learnings, what we do, we'll get the libraries available, more data we'll get, so the learning becomes faster.
Yes,
So
you can use.
yeah, so that kind of libraries are available with you. Means suppose you are already doing. So tomorrow I want to develop something for a specific battery.
See,
So
some libraries already available in Google also. You can search. Okay. Some of the website. For my case, whatever the libraries I actually needed, so I have downloaded. I have just made those libraries. Everything has not been downloaded. Okay. So you have to make your own libraries also. So in my case, I have developed some of the libraries for my project. And
So
in your
data
project,
set,
you can develop your own libraries from
right.
the various resources available in the internet.
Right. And so data set size, like, maybe how many samples on like you trained, like a 10,000 samples or
You
is it?
can use see, say 10,000, 20,000, many sample. When the sample number is greater than the actual number, that
Yeah,
will
yeah.
be best. That will give you the best value. Okay,
Okay.
because the machine learning model will learn how the uh, uh,
Right,
what are peripherals are going inside the data. Okay,
right.
so the
Yeah.
data in like the data sets, whatever the data sets available, as per
Okay.
the data set, uh,
Right.
your model will be trained. Okay.
So in this case, lithium ion or lithium ferrophosphate or which any specific battery, like battery
Uh,
technology.
Basically, specific battery, I actually not the background for the PMS. Okay. Uh, you can just search it.
Okay, okay.
That will be available. Okay.
Right. Yeah. So because we are basically interested, we develop lithium ion and lithium ferrophosphate.
Mm-hmm.
So I thought if any libraries currently
No,
available, then yeah, we can share those things like that. I thought.
no. Actually, the live at my experience, those
Mhm.
libraries are not available like spoon-fed libraries. Okay, you have to
Mhm.
develop your own libraries from the different sources from the internet. Okay, you can just take the sources, take the data. You can
Mhm.
just put into the CSV file. You can train it. You can train your live data using the Python. Like you can use Colab, Jupyter Notebook.
Mhm.
Then your model will be learned. Okay, and
Yeah.
as per your model accuracy, you will get the output.
Yeah,
Okay.
that is why I'm asking that data set, the specific to the battery, if it is available, suppose some people are
No.
doing
That's
experiment.
specific. That is not available in our
Acha.
lab. But I
Okay.
think you can just download it
Yeah.
from the resources, or you can take it from the
Uh,
other resources.
okay. So in your case, you developed the data set also. That means it is beginning to learn. And no, you use library or you developed the data set.
Okay.
Hello. No.
So we are doing that. Actually, we are doing that from many days.
Okay. Okay.
Okay. So the data set has been available.
Okay.
Okay. Any more questions?
Is there any other query? Please let us know.
Okay, sir. Thank you very much.
Sir, can you explain the double block parameters? Can you explain about the double block parameters?
Sorry.
There has open the block here showing output minimum, output maximum. How to select output maximum, output minimum? Can you explain about the blocks, sir? Double.
Wait, then I have to reshare it again. Wait.
No question. In the rate transition block, there is a sample time. We have given 0.15. How to select the sample?
You can give a sample time as per your requirement. Okay. In my case, it is 0.15. In your case, it should be, it may be 1, it may be 0.5, like that. The sample time is not necessary. Like this is not hard coded. Like if you have to give 1.5 or 0.5, like that. In as per your requirement, you can just go to the
settings, and you can just specify the sample time also.
Okay, sir.
Okay, that is not hard coded. Like you have to give 1.5 also, 1.5, 1.6 like that. So anything else? See, if when you just work with C2000 microcontrollers, that time you have to face many problems. Okay, I have already discussed some of the parts, but when you just try it by your own, that time the learning will be completed. Okay. So I think no more questions.
Okay, I think there is no other questions. Okay, thank you for discussing a lot of things. I hope that participants also able to understand and also share their own knowledge. So that is a very good interactive session, I think, and it will be quite helpful to all of us. Okay, so thank you, and just for a moment. Yes, we are going to start the next session. Okay, within 10-15 minutes. Okay, please be keep with us.